One eternity later.
Now, let's come to the RTOS architecture about our robot. It has 5 tasks in total, as shown in the diagram. The UI interrupt handler receives the data and passes it to T-Brain to decide the corresponding action. At the beginning, when T-Brain receives the initialize packet, it will set the start flag and allow the T-Audio and T-LED thread to start control the buzzers and the LEDs. After that, when the movement packet is sent, T-Brain will update the direction variable accordingly to motor control, and it will control the motors based on the direction variable. T-motor controls, T-LED and T-Audio will operate in a round-robin schedule, and it has equal priority. The thread T-Play End Song provides audio output for the robot at the end. It has a high gate priority, however, it is put to block state in the beginning, since the end flap is not set and it doesn't acquire the audio music held by T-Audio.
At the end of the process, we encounter a very subtle and annoying bug. While running, the bot kept losing control from the app. We suspect that it was the connections between the header pin and the breadboard. However, after trying different solutions, including taping the Bluetooth module, then our group realized that we were using the same 9V battery to power the motor system and the Bluetooth module at the same time, without realizing that when the motors are running, the current fluctuating drastically, and that made the Bluetooth module very unstable and lose connections. And the solution is simple enough. We use a separate battery to power the module. Lesson learned.